Hello, everyone. Welcome to Taiko Talk. This is researcher RJ, and I'm here together with developer Danny. Hey, Danny.
Hey, RJ.
Today, we are very excited to have Antonio, the founding team member and VP of products of Polyhedra. Polyhedra provides zkBridge based on an advanced zero-knowledge proof technology with backing from notable investors such as Finance Labs, Polychain Capital, and Animoca. And recently, Polyhedra and Taiko have announced their collaboration, which has the crypto community buzzing with excitement. Taiko is a leading Type 1 zk EVM Layer 2 solution with support from investors such as Sequoia China and Generative VC. Additionally, Ethereum contributors like Tim Baco and Anthony Sassano have also participated in the round. And without further ado, let's dive into the details of this exciting partnership together.
And just a quick reminder before we start that whatever we talk about here is strictly educational and not meant to be financial advice.
Great, let's start. Very happy to have you here, Antonio. Thanks for joining us today. So to start off, maybe can you briefly explain what Polyhedra is and its core differentiation?
Yeah, of course. So here at Polyhedra Network, we prove the fundamental zero-knowledge proof algorithm for the entire Web3 space, especially focusing on the interoperability track. So basically, we invented, designed, and implemented what we call zkBridge. It is a trustless and efficient cross-chain protocol that brings interoperability for the entire Web3 system, including layer 1s, layer 2s, and even we will include Web 2 in the future.
Okay, I would ask zk in terms of like what do you aggregate things off chain, and then this is why the zk, so you have a succinct proof, and this is why not ordinary like bridging solutions. This is the key of zk bridging. So you aggregating messages off chain, and from cost perspective,
yes,
you compress, and then that's right.
Yeah, so succinctness is one thing that we look for when we research on zk proofs. But that's one thing we can utilize in zkBridge. But there are several advantages of using zkBridge compared to traditional bridges like MPC bridges. So it lies on two categories. First is security, then is efficiency. So we can start from the security part. As we know, zk is famous for its security. People use the originality of zero-knowledge proof. The zero-knowledge part consists of a security encapsulation. But what zkBridge really brings is the trustlessness of the security setup. It's the trust assumption that we are changing for the bridging space. So imagine in a traditional bridge, if you need to send a message from the sender chain to the receiver chain. So what traditional bridges do, they help you to watch the status of the sender chain, whether a transaction happens or not. Then the traditional bridge help you to relay the transaction to the receiver chain. But that depends on a third party, whether it is MPC or it is relayers or it is another relayer blockchain. But you have to trust a third party to help you to watch the status of the sender chain. If that third party is hacked, or in the most easier case, if we physically intercept your message of that cross-chain messaging, we are able to maliciously change the result of the cross-chain bridge. For example, if for a traditional token bridge, if I want to cross-chain transfer 100 USDT from sender chain to receiver chain, what I do in most of the cases, say we are using a liquidity pool setting, I deposit 100 USDTs on the sender chain. And the third-party relayer or anything MPC find that transaction and tells the receiver chain, hey, 100 USDT is deposited. Now you can retrieve 100 USDT from the pool on the receiver chain. And that's the traditional token transfer process. However, if I'm able to intercept that message, if I'm able to either hack the third-party nodes, or if either the third-party nodes collude to try to steal your money, they can tell the receiver chain, hey, it's not 100 USDT, it's actually 100 million USDT that is locked on the sender chain. Since your receiver chain knows nothing about sender chain, you have to trust that third party, you have to trust that relayer. So then you basically allow 100 million USDT to be retrieved from the pool on the receiver chain. So that's the problem of the traditional bridge. So there's no validation layer, where there is no trustless validation layer. You have to trust someone, some party, some node, some organization for that message relay. So, well, coming back to the topic of zkBridge, what we bring is a validation using zk. So essentially what we do is on the sender chain, when the transaction happens, the transaction happens in a block. So what we do is we prove the consensus of the block, as well as a transaction inclusion proof, proving the transaction is actually indeed in that block. Then we pack these proofs together and deliver that to the receiver chain. So on the receiver chain, there is actually a updater contract, a smart contract that automatically receives and verifies the proof generated on the sender chain. If we are able to verify the proof, then we are able to do certain logics, is either token minting or liquidity pool retrieving or any other cross-chain relaying on the receiver chain after that proof is verified. So in this setup, we actually have a validation layer using zk that is, we are able to generate a proof of the consensus of the sender chain. Basically, zkBridge, then we are basically exactly the same security as the sender chain consensus level. So that's what we bring. So that's well, I'm gonna go a bit longer. So that's only the security part of the advantages of zkBridge. So besides security, we also have another part called efficiency. So efficiency is actually composed of speed and cost. So that together, we call it efficiency. So regarding speed, we invented zkBridge. We wrote a paper, many years ago, like 2018, when we started that algorithm research. We're able to make the algorithm super fast. By super fast, we mean it should be done within seconds. The minimum requirement that our product team has for the bridge engineer is that you have to generate a proof within the block time of the sender chain. What that means, you have to generate, within 12 seconds for Ethereum, then you have to do that within 3 seconds for Binance Smart Chain, etc. So we would like to generate a proof within the block time so that we can finish the proof of the previous block before the next block comes out, so that we can catch up with the speed of the blockchain. So that's one thing. The other thing is actually cost. Well, many people will say zkBridge is, people think zk are expensive to make the zk proof generation super fast. Then we also optimize the cost by batching them together. Well, imagine if you want to make 1,000 transfers across the chain. Traditionally, you basically have to watch them one by one. You have to see if this transaction goes through, then relay it. And verify that on chain. So what the zkBridge brings is that actually you can use the zk to wrap all those things together. We can wrap the proof of the block headers. We can wrap the proof of the transactions all together. Then maybe 100 transactions, we can verify them at the same time on the receiver chain. So by that batching algorithm, we are able to make zkBridge even cheaper than traditional bridges. So, those are a little bit long, but those are the advantages: security, efficiency. Well, in efficiency, we have cost, then speed of the bridge.
Interesting solution. Cool. Go ahead, Danny. You want to?
Yeah, cool.
Yes.
I would just argue just a little bit on the point one was like trustlessness. Of course, I think so. Traditional bridges with authentic inclusion proofs, like regular ordinary bridges, I would say can be as secure as zk bridges in a way of like, of course, you need to trust, for example, to Taiko implementation for sure. But once Taiko's implementation is audited and ready and others, like it's still as secure as zk. For example, you can use and generate your proofs off chain for Merkle proofs on source chain, and then submit that proof on the destination chain. And of course, if the smart contracts are, let's say, hacked because of update keys are stolen and someone upgrades the smart contracts on the destination chain, funds can be stolen, sure, but also it applies to zk bridges, because the zk has also some smart contracts deployed on source chain and destination chain. So I would say that I think both zk and traditional bridges could be as secure and as trustless the same way, I would say. So one example is exactly with Taiko's smart contract is like we have a message on source chain. We have a relayer service which relays that message, which message contains, for example, how much ETH or DAI or whatever you send to the source chain's vault. And then that message is emitted. Of course, it's stored in the smart contract, and the relayer service would pick it up. So, and on the destination chain, it would emit those tokens, right? What would happen if this relayer is gone? So, like the backend is gone, is that we could just shoot up our own proof service, just getting the storage proof from the and gathering or querying the proof from the source chain, and submit our own proofs to the destination chain, releasing our funds. So in this point of view, I would say it's still as trustless as a zkBridge in this setup. So if Taiko is gone,
in that case, it's the same setup. For us, it's the same. Yeah, we are able to have the decentralized proof system where anyone would be able to submit the proof to the updated contract on the receiver chain. So as long as there's one honest node still alive in the system would continue going. And also zkBridge wouldn't allow false positives. So one thing that we can guarantee is that if something doesn't happen on the center chain, there is no possibility that a fixed proof would be verified using the updated contract. So you have to be something that indeed happens on the center chain and is agreed by the consensus mechanism of the center chain. Then that's the only thing we're able to verify. If you want to trick the bridge by generating like a false proof, like malicious handwritten false proof, that proof wouldn't be able to pass the verifier system.
Yep, thanks.
Thanks for the explanation. Yeah, and back to what we just announced about the exciting collaboration. So my next question is about how did this collaboration between Polyhedra and Taiko come about? Like what sparks the idea of working together?
Taiko is a zk rollup. Polyhedra is a zkBridge. So one thing we're thinking, zk rollup plus zkBridge is actually the zk full stack. Well, one thing actually we're trying to solve about layer 2s is the finality of layer 2s. We do want to reduce that because for, say, optimistic rollups, you have 7 days, 14-day challenge period. Since zkBridge relies on the consensus of the center chain, but layer 2s have no consensus. So basically in zkBridge setup, we have to rely on the layer 2 consensus of that layer 1 consensus of that layer 2 chain. Well, basically, say if you want to bridge from Arbitrum, then we still have to rely on the consensus of Ethereum. However, Arbitrum or optimism, they do take some time before their transactions can be finalized on the layer 1 chain. Then we can rely on the layer 1 consensus. However, actually Taiko would be quite different. zk rollups would be quite different because we actually are able to utilize the zk proof of Taiko and fit that into zkBridge because zk rollups finalize much faster than optimistic rollups. So that's one advantage that we are taking. And also, in zkBridge system, in our belief, we believe in the scalability of Ethereum in the future. We believe in the ecosystem where their layer 2s would flourish. So there will be maybe a certain, a few layer 1s, but with a lot of layer 2s that would reduce the cost and actually make the ecosystem more accessible to general users. So I think Taiko is on the frontier of such development of zk rollup with very nice, type 1 Ethereum compatibility with very nice deploying experience. So we do believe Taiko would be a successful rollup for developers and end users.
Cool. And so the establishment of the Polyhedra zkBridge on the Taiko chain is definitely a significant move. So just here to educate like regular users or viewers, could you please explain what zkBridge is and maybe also highlight the differences between like regular ordinary bridges?
And please explain in a simple manner. I know it's a very pretty technical.
Yeah, I'll try not to use any technical term because we do face a lot of non-developer users. So one thing we're keep talking is that in this multi-infrastructure Web3 world, we focus on infrastructure, but we aim to bring the best user experience. So using zkBridge, you will experience fast, secure transfer for your assets. Basically, the finality, the time it takes for you to finish the transfer would be within seconds. It's actually from our liveness testing, if you do want to transfer, say if you want to transfer from BSC to Taiko, that takes approximately 30 seconds for a transaction for the entire transaction. That includes submitting the transaction on the sender chain and then finalize on the receiver chain. It depends on the receiver, how fast the receiver updater can run, but the proof generation and plus the delivery of that proof would be within 30 seconds. And actually the proof generation is within 3 seconds for BSC. So basically using zkBridge, it's very fast and also it's very cheap. So the cost of zkBridge will be like, in some of the cases will be 0.1 USD equivalent for a transaction or maybe lower. And that's for an NFT transaction. For FT transaction, it could be, we are managed to make it even lower using the batch algorithm. So generally a transaction would be like 0.1, 0.2 US dollar for the cost.
And with the upcoming Cancun upgrade, I think this cost will be even way more lower, right?
Yes. So we believe in a cost-efficient ecosystem where things should be affordable to users. That's one of the reasons why we're helping rollups on Ethereum, because it's really hard for you to interact with Ethereum layer 1 directly. That would be too costly for end users. So rollups and alternative layer 1s, we aim to bring a fully interoperable ecosystem where users can freely use any of the chains as they want.
So are you aggregating with zk, or you do it on a per transaction basis?
We are still doing, we're doing a block basis. Basically, what we can do is we can handle all of the transactions within one block at the same time. But for now, we're still handling the block basis because different blocks have different signatures. So we still need to verify different signatures in different blocks to make sure the security of the consensus of the block. Regarding aggregating, it's actually for zk we can aggregate different blocks. We call it batching, because we can batch the consensus, the signatures of different blocks. And we're talking about regarding even different chains. We would be able to batch the proofs of different chains. But that would be a problem more come to the application layer. So how applications want to handle the multiple assets across multiple chains. But in the zkP technology realm, we are able to batch them together and submit one proof to include all those transactions, all those blocks together. But it's more of a matter how applications want to handle it.
I see. I was just asking because of like a cost perspective, like how costly, the proof, but you already answered it. So thanks.
Mm-hmm.
Yeah, and
basically, it's for a block. It's the same price. Mm-hmm. Yeah, please.
Yeah, I'm actually curious, like just now when you explained the zkBridge, you mentioned using NFT or FT tokens, like fungible tokens as example. So I'm just curious, like how about like other messages like other than NFT or ERC20. So because I know, like, for example, Taiko's bridge is only an layer 1, layer 2 bridge. So it only works like natively, I would say. So Taiko's bridge can bridge all assets and can do any cross-layer message calls. So I'm not sure whether, like, what can people do with Polyhedra bridges? Is it only NFT and ERC20, or can they like do something such as like calling Uniswap on layer 1 or layer 2?
Yeah, of course, it's more than that. So what zkBridge does is a message relaying, or it's actually in the more fundamental, it's consensus proving. But regarding message relaying, that message can be fully customized. If you, we actually do have a service on zkBridge.com. It's a general message parsing protocol, which we allow users to input any types of message. It could be a general message, it could be text, it could be strings, it could be a piece of code. So anything can help you to relay with zkBridge, well, including the FTs and NFTs. So basically the logic behind FTs and NFTs is still message relaying. Well, for example, NFT, if you want to transfer an NFT from sender chain to receiver chain, the message being released through zkBridge is actually the sender chain would have a message, would have a transaction locking the NFT. Then the message would be the lock of that NFT, and that message will be relayed to the receiver chain. So what receiver chain receives is, hey, the NFT is locked on the sender chain. Now you can release that minted copy on the receiver chain. So basically, we are able to support any types of message across the bridge.
I see, understand. Thanks for the explanation. So now let's go back to our collaboration. So yeah, so how will this collaboration benefit both Taiko and Polyhedra users? Like, what can they expect in terms of enhanced features or capabilities?
So one thing, well, we're running is the Pandra King campaign. So now you can find the Pandras on Taiko, which is a very lovely pinky Pandra with Taiko logos where you can collect. Well, so that brings the interoperability feature. So Pandra natively is actually a multi-chain NFT. So what we bring is we help users to easily access Taiko. If you imagine, if you hold assets on on Ethereum already, or not Ethereum, because Taiko is a EVM layer 2, so that should be natively supported by Taiko native bridge. If you hold tokens, for example, Binance Smart Chain, then using zkBridge, you can easily move your tokens to Taiko to play in Taiko ecosystem. And also what we support is that developers would be more easy to integrate with the Taiko system. Well, for Taiko ecosystem, imagine you are a developer, you already have a D app on a different chain, and you also deployed your assets on a different chain. But you have, well, that different chain, we don't know which chain that is too expensive, or it's too slow, or it's not secure as you want it to be, or it's not EVM compatible as you want it to be. Now you want to relocate to a different chain, because we know Taiko is, well, cost efficient, and it's, well, very secure, it has very fast finality, it has all those benefits. So you can actually use Polyhedra zkBridge to bring all your assets and data and your users all together to Taiko and keep developing on Taiko with all your previous user bases, with all your previous assets. So that would enable an easy migration from any chain to Taiko. So basically you can start build on Taiko with all your previous foundation from the day one of Taiko launch. Well, and also in the future, if you want to build a multi-chain ecosystem with Taiko together, you can use zkBridge to easily make any transfers from Taiko or to Taiko. So your users will be able to freely choose any chains they want to play with, well, including Taiko, of course. So that will become a more, because I know Taiko is, well, it always keeps open source, keeps developer-facing community. So basically want to bring that permissionless protocol to the entire space, where Taiko is an important part of the space.
regarding this permissionlessness and decentralization. So one question I have regarding the security aspect. So how trustless, permissionless, and decentralized zkBridge is? For example, what happens in just really in an imaginary situation when Polyhedra stops existing from one day to another? Of course, it's not going to happen, but what happens in this case? So my bridged asset from the native chain to Taiko, can I bridge it back, or how would it work?
Yes, of course, because, well, we have smart contracts on chain. Even in the worst case, well, one day Polyhedra suddenly, well, is taken by the aliens. So the smart contracts still on chain. We still have the blockchain. The smart contracts are still working, and also the prover. Well, we would have a decentralized prover network, so it doesn't have to be Polyhedra generating a proof. So anyone would be able to generate a proof using our zkP scheme. Then, as long as you are able to generate a proof and submit the proof on chain, then the bridge would keep running. So it doesn't have to trust anyone. There is no single point failure in the system. Well, regarding permissionless, that's a infrastructure level permissionless. Well, we also have the application level permissionlessness. So for developers, we have all the bridge contracts on different blockchains. We have the zkBridge endpoints. So developers can freely access those endpoints while utilizing zkBridge technology to build a multi-chain application based on that. And from user level, user can, well, you can even directly call the application contract of zkBridge. You don't even have to go through the Polyhedra interface. You can directly interact with the applications, with the smart contracts that will be always existing on chain to utilize zkBridge from an end user point of view. So we do try our best to promote this fully permissionless system where zkBridge should be more of even a public good. Anyone would be able to use zkBridge, and any chain, this zkBridge would be deployed or try to deploy it on all the chains so that different chains can utilize zkBridge.
That sounds very promising. Yeah. So I actually have a very technical newbie question. So I guess like among three of us, I'm the only person who has no technical backgrounds at all. So I'm just curious, like this question can also be for Danny. Yeah. So I want to ask both of you, for example, like now Ethereum is the layer one, right? So when we bridge something from Ethereum to layer two, for example, Taiko, so let's, okay, for example, CoolCat. So we are going to use the Taiko's native bridge to bridge this CoolCat NFT from Ethereum to Taiko. And what happens if I'm going to use Polyhedra chain to bridge this NFT back to the layer one? So after I bridge the CoolCat from Ethereum to Taiko, I will get a wrapped CoolCat, right? And then after I use Polyhedra chain to bridge it back, will I get the CoolCat, original CoolCat, or will I get a wrapped CoolCat? Does this, I don't know, like, does this...
Well, you see the NFT, that will be wrapped.
It's a wrapped.
Yeah, it's a wrapped token. So you would not get back the original CoolCat. So it's a general rule of thumb. I would say that use the bridge for bridging back NFTs, especially NFTs than what you used before, right? So, but that's a good question. That's a great question.
So that's actually a very common practice nowadays among all the bridge, right? You have to use the bridge that you used to bridge back.
Well, yes, that's a common practice, because imagine you have a Bored Ape on Ethereum. Of course, you want to get it back when you bridge it back. But we are actually exploring the possibilities. Actually, I just had a meeting right before this one, talking with our game partners about potentially of non-lock mint logic for game assets. Because if you have, say, a lot of game assets like swords or just a piece of, well, something in-game asset, it doesn't have to, maybe you don't care about whether it is the original asset. As long as when you bridge it back, you get the same type of asset. That's kind of follows the ERC 1155 logic, because if all the things are the same, it's like a fungible, non-fungible token, then it doesn't matter if you get the exact original piece. Like for ERC20 token, there's like no original piece of that piece of USDT. So in that case, we can actually implement a burn mint logic for the bridge, so that we actually burn the original assets, then mint another asset on the receiver chain. Then when you bridge it back, it's gonna be the same contract, minting the same type of copy that you had on the sender chain. So that's another possibility, because that makes the logic a little clearer for game projects to handle.
Regarding these zk rollups and layer 2 solutions emerging up from the ground, right? How do you see the trend? How do you see the landscape of this and this trend, the L2 trend evolving? And where do you see Taiko in it?
Especially after the collaboration with Taiko, with all the developed experience.
Yeah, of course. So well, firstly, as a bridge, we are neutral for layer 2s. Basically, we welcome all layer 2s. We are, as you can see, we in 2049, we are our good friends with all layer 2s. We support the layer 2 ecosystem because, well, in our belief, we know layer 1s are too congested, like Ethereum. You know how expensive it is right now. So we believe layer 2s will be the solution in the future for all the applications, for end users especially. So we can expect a multi-layers already come. But in that layer 2 future, what zkBridge brings here is the power of choice for developers and users. Basically, if you are looking from a Web2 point of view, we talk about next billion users every day. So if you are indeed a Web2 user or Web2 developer, when you come to Web3, there is a problem is which chain you want to choose. I have Web2 friends, they come into Web3 asking me, hey, which chain is the good chain? Which one should I choose? Which chain is mostly suitable for my application? Well, that is a hard question for us to answer. So when we start bridge, we tell them, if you're using zkBridge, it's not a problem anymore. You don't have to limit yourself on one chain only. Since we're in the multi-chain world, and we believe users of course are multi-chain. We play on all different chains, but projects should be multi-chain as well. Well, people are also asking question, hey, which layer 2 is better than the other? Well, from our perspective, there's like no better layer 2. There is just a more suitable layer 2 for your application. Basically, what we want to enable is that for developers, one day you can choose any layer 2 you wanna deploy on. So layer 2s have all different technologies. We see OP stack, we see zk rollups. There are even like sovereign rollups. There are or like Arbitrum. There's different types of rollups. They have pros and cons. What we want to do is that developers can utilize the pros of every layer 2. Depending on different logics, layer 2s must have its own advantage in certain field, whether it is security, whether it is efficiency, whether it is scalability, it's cost efficiency. So what we want to bring is that when user come to the space, when developer come to the space, they can choose the chain that match their interest best. Well, that's for a zkBridge point of view, because we stand neutral for our chains. We believe every layer 2 will be able to will be successful in the future. It's just a matter of which field you want to go into. So for Taiko, we love Taiko. I actually have your Taiko swag as well. Probably should wear it today for the interview. So regarding deploy on Taiko, because we just deployed a zkBridge endpoint with all those sender chains, receiver chains connecting to Taiko. So Taiko as a type 1 zk rollup, we find it's very easy to deploy, to be honest, because when we are talking to our developer team, basically we can just reuse our smart contracts other well, then deploy that on Taiko directly. To be honest, it took us maybe less than a day, maybe like half a day, to deploy the zkBridge, all the smart contracts, and have it working on Taiko. Then maybe a day or two testing, and that's it. zkBridge is live. So it's super easy to deploy, perfect compatibility and perfect developer experience. So we believe Taiko will be successful in the future in terms of developer experience, because it's just too easy. Well, the good thing is, regarding the interview, the good thing is Taiko is very easy to deploy. The bad thing is, because it's too easy, I don't have much to talk about. Because it's just, well, you have another smart contract, then deploy on Taiko, then it just works. So there's like nothing more to talk about for user experience on that.
Thank you. I had this question on my list of like asking the developer experience, but you already answered. So thanks. That's great. Great to hear that.
Yeah, great to hear that. And actually, that's also one of the common feedback we received from our community. Okay, here we comes to the last question. So what's next to come on Polyhedra's roadmap, and what you are excited about and want to share with both of our communities?
Yeah, of course. So one thing that we'll be keep doing for maybe years is to connect to more chains, because we want the whole ecosystem to be more interoperable. So we want developers will be able to choose all different chains. Well, zkBridge actually supports all different blockchains as long as the blockchain has consensus, or the layer one has consensus. As long as you can run the smart contract on the blockchain, we would be able to support the chain in blockchain in zkBridge ecosystem, because well, essentially zk is chain agnostic. So we don't care about whether it is EVM, whether it could be Cosmos, it could be even be Solana proof of history consensus, be able to support. And going to a broader view, so for Polyhedra, our vision is everything should be interconnected, no matter it is blockchains or even Web2 world, because essentially zk technology is not a Web3 specific technology. The paper was actually, I think it's written when it was like 1985 something, when the internet just barely emerged. So zk can actually be used more than Web3 setting. We can even incorporate Web2 in this huge ecosystem. Well, one thing we can do is that for Web2 users, you have all your Web2 credential, you have your Web2 assets. We can actually prove your Web2 credential and Web2 assets and have that verified on-chain, then bring the next billion Web2 user to Web3 as well. So that's actually in our roadmap as well. So we would like to expand our boundaries to more blockchains and to more industries, including Web2 industry. Well, that's the long term. That's the long-term view. For the short term, well, we are happily collaborating with Taiko, and also we are collaborating on all different campaigns. Or the Pandora King campaign is just a start, to be honest. We want to promote the idea that assets and applications should be multi-chain. So we'll keep promoting that in the coming month, which I wouldn't disclose for now, but we have something bigger coming in for next month, where we want users to experience the true multi-chain technology, the true multi-chain user experience, where assets, data, and everything can be moved easily around different chains, while you utilize the advantages, as we just talked about, the advantages of all different blockchains. Or different blockchains have, well, different suitable applications, and we will also promote that idea in the coming session. So basically, we want users to one day have a feeling that shouldn't be limited by blockchain anymore. Shouldn't be worried about, well, getting gas on different chains to make transactions. You shouldn't be worried about having your liquidity only limited on one chain. Shouldn't be worried about having your credential, your identity only be limited to one chain. So all those data assets will be interoperable, and we'll have a taste starting next month for a fully interoperable multi-chain application coming out.
It's great. It seems something like chain agnostic platform or chain abstraction kind of thing, right?
Yes, exactly.
Cool. I'm stoked to.
Yeah, sounds very exciting, very interesting. Really looking forward to that.
Yeah, so well, lastly, following our collaboration, well, Danny, if you have anything else to share with us, what's the roadmap for Taiko? What's anything exciting coming in for the Taiko ecosystem?
Sure. I will try. I cannot really zoom out to give you a multi-year roadmap, of course, but the road to mainnet, I would say, is that we definitely. So we just launched a new A5 testnet Polyhedra just deployed on, right? We are trying to launch a new testnet still this year, Q4, testing multi-proofs, so fallback solutions to our zk technology. So we are operating with zk now, but not full coverage. Of course, we would like to increase the zk circuit coverage, but as a fallback, we are having conversations to include SGX and different multi-proof systems in the testnets. We are aiming to have a mainnet launch something around Q1 next year. Still that we have this testnet, the next A6, I just thought about this multi-proof systems. And we also need another one with the blob data. So we are depending on the proto-dank sharding, so the EIP, the Denkun hard fork. And after that, hopefully we go to mainnet soon. That's the TLDR version of our current roadmap.
Awesome. Well, we're really looking forward to it, and we'll keep participating in the following testnets. Well, for either stress testing or zkP testing. Also looking forward to potential in the future, like zkP research collaboration to explore the boundaries of zkP in rollups and in bridge.
Awesome. Here we comes to the end of today's interview. And thank you, Antonio, so much for your time and your interesting and valuable sharing.
Yeah, thank you. Well, thank you, Rita. Thank you, Danny, for this amazing session. Well, we'll keep building what we want is build together for the Web3.
Amazing. Cool. Thank you, guys. Bye.
Bye-bye.